All right, so we're going to move forward here into 3.5, solving exponential equations and logarithmic equations. The first few examples are going to be all exponentials. The first property that we're going to talk about is a one-to-one property, and that simply states if you have the same base equal to the same base that's raised to an exponent, you set the exponents equal to each other. I mean, it's simply said if I had like 3 to the x plus 2 is equal to 3 to the fifth power. These threes are already equal, so I can set x plus 2 equal to 5, subtract the 2, and get x is equal to 3, and that would be my answer. Okay, now that it doesn't always look exactly that neat. Like I could have 5 to the x minus 4 is equal to, and then I go 25 to the third power. Well, 25 and 5 clearly aren't the same, but I can write 25 as 5 to the second power. So then I could rewrite this as 5 to the x minus 4 is equal to 5 to the sixth, and then you could set x minus 4 equal to 6 and solve that. So we're going to get into a few examples here. First one, we are going to use that property here. And the way that this is written, I've got 20 times 1/2 to the x over 3 powers equal to 5. Okay, so the first thing we got to do in these problems is get whatever's being raised to the exponent by itself. So this 1/2 is being raised to the exponent, so I'm going to get rid of this 20 by dividing it. And that gives me 1 over 2 raised to the x over 3 power is equal to 1 over 4. Well, right here, I can see that these are not the same base. But I can rewrite 1 over 4 as 1/2 squared, right? 1/2 times 1/2 is equal to 1 over 4. So these are equivalent statements. So then now, because these are the same base, I have x over 3 is equal to 2. Multiply both sides by 3, and you get x is equal to 6. Okay? So that's when you have a same base or can create the same base. Now, when we look at this next example, you can clearly see I'm not going to be able to make 1.06 equal to 4.1. I mean, you're not going to be able to do it. So what we have to do is, one, we have to get whatever is being raised to the variable exponent by itself. Okay? Now, in this case, it's really simple. The variable exponent is already by itself. This 1.06 is what's being raised to the variable exponent, so I don't need to worry about that. So the second step is we're going to ln both sides. So we're going to take the natural log of both sides. Okay, it's a mathematical operation. So I'm going to say ln of 1.06 is equal to 1.06 raised to the x is equal to ln of the 4.1. Now, why did I do that? Because we went over properties of logarithms yesterday, and I can move this x out in front now. It gives me x ln of 1.06 is equal to the natural log of 4.1. And now to get this x by itself, I can simply divide by the natural log of 1.06. Okay, so I've got x is equal to natural log of 4.1 over the natural log of 1.06. I'm going to use my calculator here, and I'm going to go natural log of 4.1. Make sure you use parentheses, close the parentheses, and divide that by the natural log of 1.06. And that gives me a x is equal to 24.251. Okay, so x is equal to 24. What was it? 251, 215. Whoops. 24.215. Let me switch those two over. Now, look, when you do this, you can check your answer. Okay. So I pull that calculator up and understand we rounded here, right? So we did round this. But if I put in 1.06 and I raise that to the 24.215, we're solving equations here, it's going to give me really close to 4.1. Why isn't it exact? Because I rounded. If you don't round, then you'll get the exact answer. If you don't round, then you'll get the exact answer. Okay? So let's take a look at another example here. Okay, so get the variable exponent, get whatever's being raised to the variable exponent by itself. Well, right here, this e is being raised to the variable exponent. So I'm going to divide both sides by 50. That's going to give me e to the 0.035x is equal to 4. So now I'm going to ln both sides. So natural log of e to the 0.035x is equal to the ln of 4. What do? I take and move this out front, 0.035x times ln of e is equal to ln of 4. So I'm going to stay with the same way that I solved this. But again, what does ln of e mean? That means e to some power equals e. This is the same thing as writing down the number 1. So I don't really need that there. But I'm just going to go ahead and divide to stay consistent. Divide by the ln of e. So now 0.035x is equal to, and this, when I divide this, ln of 4 divided by ln of e, again, this is equal to 1 because this says e to some power equals e, and that would be 1. So this is the same thing as 1, gives me the natural log of 4. Now you can put this in the calculator right here, and you'll get a decimal, and just use that decimal, 0.035. When you do that, do not round till the end. Okay, so then I put this in my calculator, natural log of 4 divided by 0.035, and that will give me x is equal to 39.608. Okay, and again, you could go back and plug that in, and you should get something very close to 200 when you plug that back in for x. Okay. Go ahead and take a look at this problem right here. Very difficult problem. There is one like this in the notes, so I wanted to make sure I went over this right here. So what does this say? This says e to the x minus e to the negative x all over 2 is equal to 5. So the first thing I'm going to do is try to get rid of this fraction and simplify these e to the x's. I don't want any negative exponents. So I'm going to multiply both top and bottom. I'm going to multiply both sides by 2 e to the x. Why did I choose 2 e to the x? Because it's going to get rid of my fraction. And then I've got to distribute this to both. E to the x times e to the x is e to the 2x. E to the x times negative e to the negative x is e to the 0, right? We're adding the exponents. And this is equal to 5 times 2 e to the x, which is 10 e to the x. So then now I'm going to rewrite this as a quadratic. So I've got e to the x to the second power. Look at how I'm writing this. Minus 10 e to the x minus 1 is equal to 0. So where'd the 1 come from? That's this e to the 0, this minus 10 e to the x. And then I just wrote this way so I can now, I'm going to sub or let e to the x equal w. So look what happens here. If I plug in a w right here, this gives me w squared minus 10w minus 1 equals 0. Right? So again, why did I do that? Because I know how to solve this. This right here, I can use the quadratic formula. 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 1 all over 2 times 1. When I go through and put this into Desmos or my calculator, 10 squared is 100, negative 4, 1, and negative 1 is a positive 4. So this gives me the square root of 104 all over 2. I'm going to simplify this as the square root of 4, square root of 26. So this equals 10 plus or minus 2 square root of 26 over 2. All these simplify to 5 plus or minus square root of 26. Now, if I go back to the original problem, I can't have this negative, this minus, because it would end up with a negative value here. Okay, so we're not going to have that value won't come out to equaling anything, and won't come out to equaling a positive 5. So my answer, again, this is what w is equal to. So I've got to rewrite this now. I'm going to say e to the x equals 5 plus square root of 26. Okay. How do I solve for e to the x? I'm going to ln both sides. Ln e to the x equals ln of 5 plus square root of 26. And what does this equal? I put the x in front. Ln of e equals ln of 5 plus square root of 26. Running out of room here. So now I'm going to divide both sides by ln of e. Again, what does that mean? This is the same thing as the number 1. So x is equal to ln of 5 plus square root of 26. I'm going to put that into my calculator. Ln 5
plus square root 26, and that is equal to 2.312. So x is equal to 2.312. This is definitely the hardest type of problem I could give you when it comes to exponentials. Now, that's a tough problem. You got to sub, and then you got to go back and solve it, and then resub back. So that's kind of gives you an idea of what some calculus stuff looks like when we call it u sub. Okay, so now we're going to look at logarithmic problems. I think logarithmic problems are really simple to solve. Basically, rewrite it as an exponent and then solve it. You just have to make sure you go back and check your answer here. So again, what's the base here? 10 to the second power, right? Base of 10 to the second power equals x squared. Well, how do we solve for x? 100 equals x squared. I square root both sides, and I get x is equal to plus or minus 10. Just make sure that it works, and in this case it does. Okay, but you get your two answers there. Okay, this problem right here, nothing changes when it's an ln or a log, but I'm going to have to use my properties here. So take a look at what this problem looks like. What did plus mean yesterday? Meant to multiply, right? So I have the ln of 3x minus 2 times x minus 1 is equal to the ln of x squared, right? Remember doing these problems right here? So now I have, that's just an exponent out in front. So now I have the natural log. I'm going to 3x squared minus 3x minus 2x is a minus 5x, and then a minus 2 times 1 is a plus 2. Okay, is equal to natural log of x squared. So now I can use the one-to-one property here, ln and ln. So now I have 3x squared minus 5x plus 2 is equal to x squared. I've got a quadratic that I can solve. So I've got 2x squared minus 5x plus 2 equals 0. Okay, so then now I'm going to go ahead and solve this and ask myself, well, how do I solve that? Can I factor it? Okay, can I factor this? So I'm going to say 2x and x, right? That gives me 2x squared minus 2 minus 1. Negative 1 times negative 2 is 2. So I'm going to go ahead and solve these now, and I'm going to get x is equal to 1/2. X is equal to 2. Now just go back and make sure that when I plug these in, they work. Okay, 3 times 1/2 is 3 over 2. 3 over 2 minus 2. This gives me a negative. Remember, I can't have a negative there. So my only answer here is positive 2. Okay, the only answer there is positive 2. So even though I get two answers, this is what's called an extraneous solution there. Okay. This problem here, same thing. We're going to use our properties of exponents. What does subtraction mean? So this is log of x over the square root of x plus 4. Where did I get the square root from? What does the 1/2 power mean? Okay, equals 1. So then now I'm going to rewrite. What's the base? Log base, if you don't see it, it's a 10. 10 to the first power equals x over square root of x plus 4. So now solving this problem, 10 to the first power is just 10. So this is the same thing as 10 over 1, right? And I'm going to cross multiply. A fraction equal to a fraction. So x equals 10 times the square root of x plus 4. I'm going to square both sides because I got to get these x's together. So I have x squared equals 100 times x plus 4, right? The square and the square root cancel, but I got to square that 10. So now I've got x squared equals 100x plus 400 in distributing this 100. X squared minus 100x minus 400 equals 0. So then now I can use the quadratic formula, which is opposite of b. A lot of quadratic formula, a lot of quadratic stuff back here to chapter 2. So I've got, oh my goodness, come on. 100 plus or minus the square root of negative 100 squared minus 4 times 1 times negative 400 all over 2 times 1. So that gives me 100 plus or minus the square root. I've got to put this into the calculator, so I'm going to type it in there. I'm not going to show it. Negative 100 squared minus 4 parentheses 1 parentheses negative 400 gives me 11,600 all over 2. Okay. So what I'm going to do from here, I'm not going to worry about simplifying this. I'm going to actually type in 100 plus the square root of 11,600 and then divide that by 2, and that gives me x is equal to 103.852. And then I'm also going to do the minus just to show you 100 minus the square root of 11,600 divided by 2, and that equals a negative 3.851. Okay, now look, if I take and plug in this negative, it gives me a log of a negative. That will be undefined. So right here is my answer. And again, you can always go back and plug that in, right? That was 103.852. So if I went back to my calculator and I plugged in log of 103.852 and I subtracted 1/2, make sure I put this in there right, 1/2 log of 103.852 plus 4 and close that off, and I hit equals, it gets me really close to that 1. And again, why isn't it exact? Because we rounded. So again, be able to use your properties of logarithms in solving these problems. This problem is exactly like the other two. I'll go ahead and do it real quick. What does the plus mean to do? It means to multiply. So I'm going to FOIL this out, x squared plus x minus 12. And over here, I'm going to use my property of logarithms and write this as ln of 2 to the 3rd power, which is 8. These are the same, right? So I can rewrite this as x squared plus x minus 12 equals 8. Subtract the 8. X squared plus x minus 20 equals 0. X plus 5, x minus 4 equals 0, x equals negative 5, x equals 4. I have to go back to the original problem. If I take this and plug it in, negative 5 and minus 3 is a negative 8, won't work. So my answer here is x equals 4. Okay, you got about 15 problems in your homework. Give them a shot. I'm going to be absent today. Well, this is for block 4, blue day. White day, I'll be there. But, if you have your questions, make sure you're asking them.